Hey, sixth graders. We're going to go ahead and start our geometry unit. So make sure that you have a copy of these notes in front of you to fill out as you watch this video. I also want to remind you to make sure you listen all the way through to the end of this video. At the end, I'm going to give you some hints about your assignment for today that will really help it to be a lot easier. So save yourself some frustration and listen the whole way through. So starting off our geometry unit, we're going to review three types of lines: parallel lines, intersecting lines, and perpendicular lines. And I should just remind you that when we use that word line, it means that we're talking about a collection of points that extend on and on infinitely in both directions. That's why when we talk about a number line, we're talking about a line that extends infinitely in the negative direction and infinitely in the positive direction. So that idea is important as we understand and study geometry lines as well. The first type of line we're going to talk about is parallel lines. It's really easy to remember these because in the word parallel, there are three L's that are parallel to each other. The definition of parallel lines is two or more lines that never cross or touch each other. So not only are they not touching now, but if you extend them on and on, they will never touch each other. They are always the same distance apart, and they don't share any points. I'm going to go through this kind of quickly, so if you need to pause the video to fill things out, by all means, feel free to do so. Take a moment, though, and look at the box and circle any examples you see of parallel lines based on that definition that they never cross and they're always the same distance apart. You should have chosen these four lines as examples of parallel lines. Remember that even though these lines right here are not currently touching, if we extend them, they will touch. So they are not examples of parallel lines. Now, when we look at parallel lines, sorry, let me try that again. There we go. I just want to point out that line segments and rays can also be parallel as well. If you remember, line segments are parts of a line that have two endpoints, and rays are parts of a line that have one endpoint and extend infinitely in one direction. So since segments and lines are segments and rays are parts of lines, that means that they can also be parallel to each other as well. Like down below here, we have an example of two parallel line segments with endpoints, and this is two parallel rays with one endpoint and one arrow. Just like other forms of math, in geometry, mathematicians like to abbreviate things to make it easier for them. So the abbreviations that are used in geometry to represent parallel lines are arrowheads. So on an actual geometric diagram, the mathematician will mark with these little double arrows, and that's just the way of communicating with you, hey, these lines are parallel. If there happens to be two sets of parallel lines in the same diagram, then we distinguish between them by using a double arrowhead on one pair and a single arrowhead on the other. As I said, mathematicians like to abbreviate, so when they write out the relationship between these lines, they use a shortcut that looks like this. So this little shorthand way of writing it uses this double L symbol, and that double L symbol is just a symbol, kind of an equal sign on its side, that's used to communicate that the lines are parallel. So this thing right here would be read as line segment EF is parallel to line segment QT. Isn't it a cutie? Haha. Over here, we have ray AT is parallel to ray OR. And again, it's just read with this short little shorthand notation for it. Parallel lines show up all the time in our world around us, and I want to show you a couple of quick examples of that. They're found in the lines on roads, the grill of this car, the support of this skyscraper, the teeth of the comb, these trees, the stripes of the zebras, and my personal favorite, piano keys. Let's move on to our second type of line on page 2. These are intersecting lines, And there's an easy way to remember what intersecting lines mean, because when you write it, you'll see that the lowercase t's in the word intersecting are actually examples of intersecting lines. The definition of intersecting lines then is that it's two or more lines that touch or cross each other. So in other words, kind of the opposite of parallel lines. Since they touch or cross, they have exactly one point in common, and where they touch or cross, they form angles. So for example, these two lines are just touching each other and they form two angles right here. These two lines are crossing one another and they form 4 angles. So try it out. Go ahead and circle the examples of intersecting lines that you see in this box. You should have circled all but these 2 examples here because those examples are parallel. Remember that examples where they just touch are also intersecting lines. They don't have to actually cross. Lots of examples of intersecting lines are found in real life. In fact, where roads cross one another, we actually call this an intersection. The ceiling of this museum, Mrs. Davis's ceiling fan blades, the pattern on this basket, the hockey sticks, pool noodles, tree branches, and torture devices for women all are examples of intersecting lines. Now, before I move to the last type of lines, I do want to just point out the logic behind these. So this might seem kind of random here, but if you think about the definition of a Dalmatian, and then you think about the definition of the dog, Dalmatian is a specific term, dog is a general term. So we can truthfully say that all Dalmatians are dogs because Dalmatians are a specific type of dog. But we can't turn that around and say that all dogs are Dalmatians because a Dalmatian, again, is a more specific term. So following that logic, our last type of line is called a perpendicular lines. And if you make capital E's, not lowercase, but capital E's, they do actually form perpendicular lines. The definition of perpendicular lines is that they're a special kind of intersecting line. So in other words, it's kind of like a Dalmatian is a type of dog. There's a distinguishing characteristic here about a perpendicular line that makes it a special type of intersecting line. And that distinction is that when they cross or touch each other, they form 90-degree right angles. So anything that crosses is intersecting lines, but perpendicular lines are the special case of intersecting lines. If they just touch each other, again, they're going to form 2 right angles. If they actually cross, they'll form right angles. And I clicked ahead too far, so I gave away the answers for this one. But your 4 examples of perpendicular lines are 1, 2, 3, and 4. It's pretty easy to spot them when they're up and down. It's a little trickier when they're turned sideways like that. But the key is that they form a 90-degree right angle. Examples of this in real life are your floor tiles, the T in Target, a clock when it reads 3 o'clock, these bookshelves, this windmill, this very flexible gymnast, and these window pane grids. Taking a look at your assignment for today, you're going to take a look at pairs of lines and determine whether or not they fit under the category that they're listed. So looking at this diagram up here at the top, you would go down through all of these pairs of lines that are listed under parallel and cross off any that don't belong. So in other words, you take a look at A, B, and C, D, for example. So we'd find those up here in the diagram. Here's A, B, and there's C, D. And then we would determine whether or not those lines are parallel. If they're parallel, we just leave it alone and keep it there. If they're not parallel, then you cross it off. And you can see that I gave you this hint that 4 pairs should be crossed off that don't belong under parallel. When you get to intersecting, there's going to be 5 pairs that don't belong there. And when you look at perpendicular, there are 4 pairs that don't belong. Just a hint as you do this assignment, though, looking a little closer down at the bottom, there's a riddle down here. And the way you solve that riddle is to write down the letters of all of the items that you had not crossed off at the very end. So a good hint for that would be the fact that there's going to be, in this puzzle, there's two pairs up here that use that same number. So for example, for number 1, there's a pair under intersecting, and there's a pair under perpendicular that both have that number 1. So either the letter J or the letter B is supposed to go down here in the riddle box. So the easiest way to do this is to look at the two pairs that have that same number, go up in your diagram and determine which one of those is true and which one is false. Cross off the one that's false, and then use whatever letter it is for the one that's true to write down here. You also might want to circle the ones that you've determined are true, just so you can keep track of which ones you've looked at and which ones you still have left to try. Don't forget when you're finished with it to text me a picture, or you can email me an image of your final copy of your assignment.